Hi, this is Somin Bharti, and welcome to another episode of TFiR Newsroom. And today we have an esteemed panel from SIOS, where we're going to talk about high availability in SAP environment. Uh, Welcome to the show, Brett and Harry. Can you please introduce yourself?
Yeah, sure. Hi, Swap. My name is Harry Aujla. I'm the EMEA pre-sales director at SIOS Technology.
Yeah, hi Swap. I'm Brett Barwick, and I'm a software engineer for SIOS Technology.
Awesome, thank you. I'm just curious, in today's world, why is SAP important to its customers or SIOS customers?
What we see is a lot of companies who are wanting to set up an enterprise resource planning system, an ERP system, because they want to improve their internal processes and the overall performance of the company. One of the more common and leading ERP solutions on the market today is SAP. And what an SAP ERP system does, it helps customers reduce some of their labor costs and some of the IT expenses for their organization, whilst at the same time helping them improve interactions between departments and teams and avoid duplication of data. Now, more importantly, what today's businesses need are innovative technologies with comprehensive capabilities that allow them to bridge the gap between business process and employees. An organization has multiple departments and multiple teams, and to manage them successfully, there should be an ERP system that supports them by coordinating all information and all communication within that organization. So what we see is, when an organization has that reliance on SAP, the more organizational reliance on SAP, the more mission critical that function becomes. And this thus increases the need for an enterprise class high availability solution to ensure the ongoing operations of SAP. I'm sure Brett can maybe add some more color around that.
Yeah, thanks, Harry. So I think that's all exactly right. I think it's really that sort of single, centralized, intelligent, high performance framework that's really attractive to customers. When you combine that with something like the SAP HANA in-memory database and the sort of performance that you get out of that, and the intelligent S/4HANA platform that's built around it, you can see why customers would want to use something like that to manage multiple different facets in their business. And just like you said, I just wanted to reiterate, I think it's an important point that when you have something like SAP that's so pervasive and it's throughout your entire business, it is really important to make sure that you're protecting against failures by installing and configuring your environment with high availability in mind.
Awesome. When you look at customers, SLAs or service level agreements are really critical to them. How does, HA kind of address maintaining SLAs that the customers sign up for?
So, high availability is a core piece of that SLA or service level agreement conversation between a vendor and a customer. What it does, it ensures that the key components of the infrastructure are protected and services can be recovered as rapidly as possible in the event of an outage. High availability can address various parts of the IT infrastructure, but with regards to SAP, what we're predominantly referring to is availability of the application itself, SAP, and its associated data, regardless of whether you're running these operations within a physical server environment, a virtual environment, or a cloud infrastructure. Brett, would you agree with that?
Yeah, I think that's right. And I think typically in terms of the SLAs that we see, a lot of times they're phrased in terms of the amount of downtime that's allowable throughout the year. And typically that's phrased as the number of nines of availability that you need. And that can go anywhere from 2 nines, so that would be 99% uptime throughout the year. That works out to be about a maximum of around 88 hours per year of downtime. You can get more aggressive. You could go to maybe a 3 nines, which is around 9 hours of downtime, so 99.9% uptime. 4 nines, you're around 5 hours of downtime per year. Even if you want to get real aggressive, you can go to 5 nines of high availability, and then you're talking about just over 5 minutes of downtime per year. And typically we see customers going with around the 4 nines, about 50 minutes of downtime allowed per year, just because that's something that you can do with high availability clustering, and you get a good trade-off between large amount of uptime and something that you can implement at sort of a suitable price point too.
If you look at SAP, they have a very broad, very wide breadth of services and product and components. Which components does HA touch, and how does it work? Can you talk a bit about that? And if you can also kind of point out some of the core components that SIOS deals with.
Yeah, sure. I think, like you just said there, it's SAP can be built up of various sort of components and services, all of which interact with each other to form a comprehensive network of functions, including pieces such as the ABAP central services, commonly referred to as ASCS, the on-queue replication server, usually referred to as ERS, and many, many more pieces that make up the SAP landscape. In addition to these services, the SAP landscape itself will also rely upon a database element, which will also need to be considered for high availability protection as well. Any good high availability solution will monitor the health of these different services, and if in the event of a service not performing as expected, or worst case scenario, a service failing completely, the high availability solution can take the appropriate action to recover that service as quickly as possible, either within the same node if it can, or if it's a node-wide problem, we can try and fail over those services to another node within the same high availability cluster. Now, this allows for minimal downtime on that service, and thus the minimal impact to the end user, which is obviously really important. In parallel to this, the database is also protected by means of replicating the data from node to node within the cluster, and having that data available on the failover node within the same high availability cluster. Now, this data protection piece can be applied regardless of the type of database you might be using. It could be MaxDB, DB2, or even something like SAP HANA. I'm sure Brett can add some more detail around that.
Yeah, so I think that's all exactly right. Just to give one concrete example of why it might be important to make sure that the resources are being handled intelligently and that you have the correct sort of data redundancy going on, would be maybe to look at the on-queue server, which is part of the central services instance. So typically either called SCS or ASCS, depending on the Java or ABAP deployment. And it's the job of the on-queue server to manage what's called the on-queue lock table. And so what this does is it sort of keeps track of which users can access which parts of the database. So to make sure when you have multiple concurrent users, you're not getting database collisions, so you're ensuring database consistency throughout. And the on-queue server process itself is a single point of failure in the entire SAP system. So if something happens to this one process, your entire SAP system is going to be down until it can be brought back up. And in addition to that, the lock table, you want to make sure is being replicated to another node in the cluster so that you have data redundancy. Because if you're able to recover the on-queue server and it's not able to recover that backup lock table, you will recover your on-queue server and get the database back up and running, but you're going to forfeit any transactions that were in progress when the failure occurred. So it's important to have an on-queue replication server or an ERS instance running on a backup node that's going to store a backup copy of your lock table so that when the on-queue server comes back up, it grabs the backup copy of the lock table, rebuilds its locks, and then you're sort of back, you hit the ground running, just like it was before the failure happened.
I mean, if you look at HA, high availability, it could mean a lot of different things. I mean, it could be about, zero downtime, or just to minimize downtime. It could be just, to kind of recover data loss or eliminate data loss, or it could also be like the data should be intact. So I'm curious about, can you talk about some of the, the high availability solutions that are there for HAP environment? And what are the, how do you ensure that, those, like whether it's downtime or data loss or data integrity, nothing is compromised?
Yeah, again, another great question. I think any good high availability solution needs to keep three core goals in mind. And I think some of them you just mentioned there, Swap. Firstly, we've got to be in a position where we can minimize the downtime on the application. We also have to be in a position where we can eliminate any data loss in that high availability landscape. And in parallel to that, and as equally as important as that, we want to maintain data integrity whilst we're managing these high availability processes. Now, how you go about approaching high availability with those goals in mind, there's a couple of techniques that customers can use to achieve these goals. Firstly, you can look at building high availability into the application itself that you're looking to protect. This allows for some core application level intelligence to be developed within the high availability solution itself. However, one of the downsides to this approach is that the high availability solution is only then built for that one particular application. So if you've got other applications within your infrastructure that also require protecting, you're going to have to think of alternative solutions for those applications. The other approach to consider, and one which I think sort of addresses the wider infrastructure rather than individual applications, is to build high availability into the infrastructure itself, allowing for a wider level of protection across multiple platforms, multiple OSs, multiple applications and databases, providing that transparent level of application recovery and data replication within the whole infrastructure.
I'm just curious that which of these two solutions works the best for the customers. Either it's ideal or best practice, or this is something that you see a lot happen.
Generally, we see most customers looking at an infrastructure level protection, and really because of the reasons I've just mentioned, they're running multiple applications within their infrastructure. So they need to find a way of standardizing their high availability to cover all of those applications and all of those operations and services within the infrastructure. The benefit for the customer is that if they're standardizing on one solution, they've only got one solution they need to manage from a high availability standpoint, rather than having to manage individual high availability solutions for individual applications. So it really sort of boils down to the benefits of managing the environment more than anything else.
Right. And if I could add real quick just to that, in a case like SAP, you're going to in some ways see both things happening, because SAP does have its own internal mechanisms to help provide high availability. For instance, the on-queue replication server is there for data redundancy purposes. And in the case of the SAP HANA database, there's built-in HANA system replication that will replicate from a database on one system to the other system. But then, like Harry's saying, it's important to have something at the infrastructure level, because just because SAP is providing these tools, you need something that's going to intelligently manage them. And that's where sort of an infrastructure level solution comes into play.
Since, as you know, we're discussing, there are two approaches. One is application, one is infrastructure. Can you just kind of elaborate, how each is handled, from application standpoint as well as infrastructure standpoint?
Okay, yes. So from an application standpoint, it's really important that we're able to monitor any important processes or services that the application needs to run successfully, and that we can quickly detect failures, act on them, and get things back up and running as quickly as possible. And the amount of time that it takes to detect a failure, act on it, and get everything back up and running, that's usually called the recovery time objective, or RTO. And it's really important to have some intelligence built into your solution, obviously, to try and minimize the amount of time that it takes to get everything back up and running. It's also important to consider sort of the availability of the data, not just how quickly can you get things up and running, but also making sure that you minimize the amount of data loss or try and eliminate it altogether. And the sort of how up-to-date the data is on a backup cluster node when you do a switchover or failover, that's typically called the recovery point objective for the data, or the RPO. And there are various types of data replication techniques that can be used to sort of try and decrease the RPO. And you can even approach an RPO of 0 if that's what's needed for your application.
So we have been talking about, HA in SAP environment. I'm curious what kind of solutions SIOS offer to SAP customers, and if you can also talk about, some of the details of the latest features of the solution that you offer.
Absolutely. So one of the key solutions at SIOS position when we come to SAP high availability is something that we call the SIOS Protection Suite for Linux. And a few months ago, we released version 9.4.0 of this solution, which is very important for us because this is the first version which is now fully certified and supported by SAP for SAP S4 HANA platform. This is via the SAP High Availability Clustering Certification, which is referred to as S4 HA CLU 1.0. In order to achieve this official SAP certification, SIOS Protection Suite for Linux was tested extensively for compatibility with the SAP High Availability Interface 7.7 and the SAP S4 HANA platform. Now, as part of the S4 HANA platform, version 9.4.0 also added support for version 2 of SAP's OnCube server replication framework. The updated OnCube server framework actually provides enhanced high availability features by allowing the ASCS services instances to fail over to any node within the high availability cluster, rather than limiting it to the node where the corresponding OnCube replication server instance is running. I'm sure Brett can add some more flavor around that.
So to facilitate some of the high availability features like Harry was talking about with the S4HANA certification, we made some modifications to the way that the ASCS and ERS resources are handled in SIOS Lifekeeper. We sort of broke apart some of the dependencies in such a way that they can now fail over independently of each other. So it gives you more flexibility in a failover situation in terms of which node your central services instance can be relocated to, and also the replication server. We also built in some functionality so that if the OnCube replication server is running on the same node as the central services instance, then it will automatically relocate itself, if possible, to another cluster node. And that's to provide data redundancy for the OnCube lock server or OnCube lock table data. And finally, we made some enhancements to the SAP high availability clustering connector interface. And the purpose of that is when a customer wants to use SAP's front-end software to manage their SAP instances, they need a way that SAP software can interface with SIOS Lifekeeper and make sure that Lifekeeper is aware that you're stopping an instance, you're starting an instance, and so that all of our cluster resources, that their states stay up to date.
And I'm just curious, how are customers deploying these SIOS, application or solutions for HAP? Because as SIOS support, hybrid cloud, multi-cloud. So can you talk about that a bit?
Any high availability topology for a mission critical application such as SAP needs to consider a couple of primary objectives. And this is sort of quite common. This is what we see a lot of our SIOS customers doing today. Firstly, the solution should be architected in a way whereby we can eliminate any single points of failure in the configuration. Cloud landscapes today are usually built up around what are referred to as availability zones and or regions. And although a high availability cluster can be deployed within a single availability zone, the availability zone itself can present itself as a single point of failure. If for whatever reason the availability zone becomes unavailable, we can potentially lose access to the entire high availability cluster and the associated data. Now, the best practice in this scenario is really to separate the SAP cluster nodes out across availability zones. So, for example, very simplistically, let's say we have a 2-node SAP cluster, And we're actually hosting node 1 in AZ1, availability zone 1, and node 2 in availability zone 2. And generally with most SIOS configurations, we also have some sort of witness or quorum node, and that can reside in availability zone 3. Now, what this gives us is the ability for the SAP application to actually fail over from availability zone to availability zone if necessary. So the idea is that if one of the availability zones did go down, did become available, we can fail over the application to an alternative availability zone and get those services back up and running as quickly as possible. In addition to that, what some of our customers also address is an element of disaster recovery. And they do this by actually adding a third node to their high availability cluster, which can reside in an additional availability zone or region if necessary. Brett might have some further detail around that with some of his customer engagements.
Yeah, thanks. So another thing to think about when you're setting up your SAP cluster for high availability, of course, it's all based around the central database piece. And so you want to make sure that the way you architect your SAP landscape, that certain processes that are running in the background are not going to sort of compromise the performance of the database. And so what we sort of see and what's a best practice typically is that you may want to have some of your core SAP instances, such as your central services instance or your on-queue replication server instance, your primary application server instance, things like that, running in their own sort of dedicated cluster, either a 2-node cluster or a 3-node cluster, like Harry was saying. And you probably want to have your database on a separate cluster, especially if you're using something like SAP HANA, something that's very, very memory intensive. You want to make sure that the different things, different SAP instances aren't fighting over resources in such a way that it sort of impedes the performance.
Can you talk a bit about, the SAP's, NQ server frameworks, and what are the kind of, advantages of version 2 versus version 1?
Yeah, that's a great question. So version 1 of SAP's standalone on-queue server framework was used for several years. And the basic framework there is that you'll have the central services instance, and within it you have the on-queue server maintaining its lock table. It would be replicating that to the on-queue replication server, which would be running on a backup node. And during a failover, if you had a failure of the on-queue server, the high availability software had to orchestrate the failover in a very specific way, such that the on-queue server would be started up on the system where the replication server was running. So essentially what that meant is that your central services instance had to always follow your replication server instance. It didn't really give you a chance to do local recovery. If you had a failure of your on-queue server, you really had to fail over to a different cluster node, and it had to follow the ERS instance. And so in a 2-node cluster, that's not such a big deal, because if there's only 2 nodes, you only have one choice of the system that you're going to relocate it to. But as we see customers using more 3-node clusters, it becomes more and more difficult in the previous version 1 of that framework, to manage how things fail over, to make sure the lock table's obtained appropriately from the backup copy. Harry, did you want to talk a little bit more about version 2?
Yeah, absolutely. So just based on the scenario Brett was describing there, version 2 of the standalone on-queue server actually addresses some of those limitations. What it does, it allows you to eliminate that issue by assigning a dedicated virtual IP or host name to the ERS instance itself. And that allows you to direct traffic to the cluster node that's currently hosting the ERS instance. Now, because of this dedicated virtual IP for ERS, the corresponding central service instance can fail over to any node within the cluster and retrieve its replicated lock table through the network. And what this does is this eliminates that ASC must follow ERS on failover requirement that Brett was talking about earlier, and creates a much more independence between the ASCS and ERS resources in a highly available cluster environment.
And is there any way for a customer to know actually which version, whether version 1 or version 2 of NQ framework server they're running, or which version of replication server they're running? And also, should they be running the same version of both servers?
Yeah, that's a great question. And that's a question that we get a lot from customers who may have installed an SAP system a long time ago before version 2 was even out, and may have since upgraded. They're not sure whether their OnQ server got upgraded along with that. So I will say, if you've done a recent SAP installation, meaning you're using SAP kernel in the ABAP version 7.53 or later, version 2 of the standalone OnQ server framework is installed by default. That includes things like if you're working on the S4 HANA platform, version 2 will be installed by default. But if you're not sure and you want to check, you'll need to go onto your cluster, and there's just a couple commands that you need to run and look at the output for. So the first thing you need to do is switch to your SAP administrative user for that particular SAP installation. So you need to identify the SAP system ID, or SID, which is a 3-character code that's used to identify the SAP installation. And the SAP administrative user is typically all lowercase. It's your SID, so those 3 characters, and then ADM. So the first thing you'll do is you'll switch to that user, which is SU dash that user, SID ADM. And then you'll run a SAP control command, which is SAP control dash NR. And then you'll put in either the ASCS instance number or the ERS instance number. It's important here that you just use the instance number, not the full instance name. And then it'll be dash function, get process list. And so you'll see some output here from SAP control. And if you put in the ASCS instance number, you want to check the version for the OnQ server. If it says OnQ server, all one word, and no version number, that means it's OnQ server version 1. If you see OnQ server 2, obviously that means version 2. And similarly for the replication server, if it's OnQ replicator, all one word, is version 1. OnQ replicator 2 is version 2. And the other question that you asked is really good too. What if you find that you're using OnQ server version 1 or version 2, sorry, maybe you upgraded the OnQ server, but you forgot to update the replication server. That's a problem because they don't work together. The two versions aren't compatible with each other. So if you want to reinstate your high availability and your data redundancy, you need to make sure that as soon as you update the OnQ server, that the replication server gets updated as well.
Perfect. And what if I am running an older version? Can you upgrade? And if you can, how?
Yeah, that's a great question too. And so probably instead of sort of diving into a lot of the technical details, there are a couple really good resources that I would encourage people to check out. These are both SAP notes. So they can be obtained by going to support.sap.com and just searching the notes that I'm about to mention. So the first is SAP Notes 2711036. That one's titled Usage of the Standalone OnQ Server in an HA Environment. This is an SAP note that was written by SAP, and it details the steps that you need to go through for upgrading to version 2 of the standalone OnQ server framework. So you'll need to make sure that you're running an SAP kernel version that supports it. And then there's a number of additional changes that you'll need to make in the instance profiles themselves. But check out that SAP note, and also the documentation that's linked to in that SAP note. It has a lot of great details about the steps you need to follow to upgrade on the SAP side. And I'd also encourage you, if you're setting up or upgrading your cluster in SIOS Lifekeeper, you're going to want to check out SAP Notes 2854919, and that's titled Upgrading from INSA 1 to INSA 2 using SIOS Protection Suite for Linux. And this is an SAP note that was written by SIOS, and it sort of picks up where the other SAP note left off. So Now you've upgraded your instances. What do you need to do in your SIOS protection suite for Linux software to make sure that it picks up on those changes and is managing the resources appropriately?
And if I'm not wrong, customers also, kind of set up their, shared file system for ASCS and ERS. So I'm curious, what is the significance and importance of these shared file systems? Second is how they can set it up, and if there are multiple ways to set it up, which one is the most common one?
Sure. So what we see are many SIOS customers, they will use an NFS configuration in which the current host for each resource acts as the NFS server for the corresponding SAP instance's file system. Now, what this means is that the file system for each SAP instance is accessible via the virtual IP associated to that instance. So in this configuration, the central services, the CSC or ASCS resource host, will also typically host the NFS share for the SAP mount file system. And one of the benefits of this configuration is that it only requires resources within the existing cluster. So it doesn't mean you have to set up additional clusters, and thus it can help you sort of minimize on some of your instance costs. That's just one configuration. That's just one way of doing it. Brett, I believe there's some other configurations that customers can look at as well.
So some other things that we see customers doing are, well, one option is to set up an entirely external NFS server or NFS server cluster that just its sole job is to share these file systems via NFS. Another option, if you're deploying in the cloud, is you can use a cloud-based file sharing solution, something like Amazon Elastic File System, EFS. We have several customers using that. Some of the benefits of using an external NFS server are improved availability. So if you're using the setup where the cluster host inside your cluster is hosting the NFS share, if that cluster node fails and you're performing a failover, while that node is down, that file system is unavailable. And you can avoid that if you're using an external NFS server or a cloud-based file sharing system. So it increases the availability of the file systems. The trade-off there is typically it's an added expense, of course, because now you're talking about using resources that are outside of the existing ASCS ERS cluster. So if you're on-prem, you need either another server that can host the file systems, or you're going to have to pay the costs for the cloud provider that's providing the file sharing mechanism.
Right. And as you mentioned, if there is a kind of failover or switchover, how can a customer check the table consistency? What is the way to do that?
Right. Yeah, that's a great question, and something that you always want to sort of look at after you've set up your cluster for high availability. Just make sure everything's working correctly. And so sort of at a high level, what you want to do is, of course, you want to switch over your resources. First of all, your ASCS resource, your ERS, your PAS, if you're protecting that with LifeKeeper also. Make sure everything can switch over successfully. And also in terms of specifically with ASCS and ERS, it's important to check the lock table consistency, like you mentioned. And the way that you do this, sort of at a high level, is you want to write a collection of dummy locks to your on-queue server. The specific utility you're going to use to do that varies depending on whether you're using version 1 or version 2 of the on-queue server framework. For version 1, you're going to use the enqt utility. For version 2, you're going to use this enq admin utility. And there's more details in our SIOS documentation. So be sure to check that out for additional details. But you can write some dummy locks to the on-queue server. Then you initiate either a failover or a switchover of your ASCS instance or SCS instance to a different cluster host. Then you wait for everything to come back up, and you're going to check the lock table again. Here you can use a SAP control command, enq get statistic, and look at the locks now parameter, and just make sure that the same number of locks you wrote before the failover or switchover are still present there after the recovery is complete. Once you've got this and you can switch over and fail over your resources correctly, then you know that you've set up the cluster correctly and you're good to go.
I'm just curious, Brett, from your perspective, when people are kind of, we talked about upgrading, some components, but when people are upgrading their SAP environment, do you have any best practice or what advices do you have for them, what to do, what not to do?
Yeah, that's a great question. And we do get a lot of customer questions when it's time to upgrade because it's a big sort of challenge, especially with SAP. There's a lot of moving parts. You want to make sure you get everything right. And so I think just sort of my final bit of advice would just be that high availability, whether it's with SAP or anything else, is pretty complex topic. And so while we do have all these sort of intelligent features to help you minimize your downtime and increase your data redundancy and your recovery abilities, a lot of how well that works is kind of dependent on how well the initial setup and configuration is done. So my advice would just be really carefully go through SAP's documentation, carefully go through SIOS documentation, make sure you're following it, make sure that you have tested carefully in a sandbox environment, obviously, before you move to testing and move to production. Just make sure that everything is working appropriately and that you followed all of the steps that were laid out by SAP and SIOS.
Awesome. Harry, if you look at today's world, everybody is moving to the cloud, they are on their cloud native journey. Do you have any advice for those people who are kind of moving to the cloud?
Yes, absolutely. I mean, we're seeing more and more customers moving their big mission critical applications into the cloud. It's usually forming part of a wider digital transformation project that these organizations are looking at. But certainly, with regards to SAP, there's a number of considerations that customers should keep in mind when moving it into a cloud platform. I think firstly, and we touched upon this earlier, I think it's important that we establish clear SLAs between your cloud provider and yourselves, and agree sort of which levels of availability are required around your mission critical applications. This goes back to identifying whether you require 3, 4, or 5 nines availability, and those different levels of availability that Brett was speaking about earlier. Secondly, from an availability standpoint, primarily we want to design the SAP landscape in a way so that we are avoiding any single points of failure in the landscape, and also in a way where we're not impacting the application performance itself and thus operating within the agreed SLAs. And then there's other key aspects in terms of general cloud design and cloud deployment. You need to keep in mind other things that could impact the SLAs, such as instance sizing, infrastructure design, security, network requirements, and so on. And certainly, if people do want to learn more about some of these elements and more about how SIOS can deliver these high availability techniques for these mission critical applications in the cloud, we've got a lot more information on our website at www.us.sios.com. So please do take a chance to visit if you can.
Awesome. Thank you so much, Harry and Brett, for taking your time out and explaining high availability in SAP environment. And I look forward to talking to you guys again. Thank you.
Absolutely. Thank you, Swapnil.
Thank you.